Got 3 warm-up questions. Go ahead and take a moment to solve them all. Pause the video. And when you're done, you can check your answers with the solutions. So first, completing the square. Hopefully you remember that when you're completing the square, you replace f of x with 0. And then you subtract the 8 so that you're left with ab being equal to c. All right, our next goal is to try to get our term on the right into a perfect trinomial. So we take half of b, -3, and square it. What we add to one side of the equation, we have to add to the other side of the equation. So 9 minus 8 gives us 1, which is equal to, well, I'm not going to rewrite the equation because our whole purpose of creating a perfect trinomial was that we know a perfect trinomial can be converted to a binomial squared. So x minus the half of b squared. Now at this point, we're solving a multi-step equation. It should be relatively familiar to you, but let's go ahead and finish it. We take the square root of both sides, and the square root of 1 is plus or minus 1. Square root of x minus 3 squared is just x minus 3. So I can add 3 to both sides, and we end up with 3 plus or minus 1 equals x. So at this point, we know that 3 plus 1 is 4, 3 minus 1 is 2. Our x values are equivalent to 4 or 2. The discriminant. What is the nature and number of solutions for the quadratic function? Well, me telling you the discriminant gave you a big hint. Hopefully you recall that the discriminant is b squared minus 4ac. Yes, it's that part of the equation that was sitting in the radical when you were solving the quadratic function formula. Couple of things we need to remember is that when b squared minus 4ac results in a positive solution, you have 2 real solutions. When b squared minus 4ac gives you a negative value, you have 2 imaginary solutions. When b squared minus 4ac gives you the solution 0, your quadratic function is going to have 1 real solution. And that's when your quadratic comes down and has a vertex sitting on the x-axis. So let's check these solutions. B is 6, so 6 squared minus 4 times a, which is 2, times -1, which is c. Now 4 times 2 is 8 times 1. Sorry, -1 is -8. So we end up with 36 plus 8. 44 is a positive number, so we'll have 2 real solutions. All right, our other problem, b squared, so 4 squared minus 4 times a times c. 4 times 4, or 4 times 2 is 8, times 2 is 16. 4 squared is 16. 16 minus 16 is 0. And so we end up with 1 real solution. Today's focus is on geometric sequences. Now, notice that we have one individual who gets around 2 individuals who each get around 2 individuals who each get around 2 individuals. Well, collectively, we have 1 individual that becomes 2 individuals, that becomes 4 individuals, that becomes 8 individuals. And what we can tell is that as we work our way down the chain, we're multiplying each value by 2. So our question becomes, what makes a sequence geometric? The geometric comes from that common ratio. So, given the following sets a number, I want you to determine whether the sequence is arithmetic, geometric, or neither. Since we just saw that geometric comes from multiplying a common ratio, hopefully you recall that arithmetic comes from adding a common ratio, and neither, well, it would either not be multiplying or not be adding a common ratio. So let's look at our first example. 4 times 3 is 12. 12 times, no, that's not 20. 4 plus 8 is 12. 12 plus 8 is 20. So we're dealing with an arithmetic sequence. All right, let's check for geometric. 4 times 3 is 12. 12 times 3 is 36. Now we have a common ratio. So our common ratio is 3, and it is geometric. All right, next. Well, what do I multiply by 1/2 to get 1/3? Sometimes it's easier to work backwards to figure your common ratio. So if we work backwards, we want to do the inverse operation. So 1/4 divided by 1/3, which is the same as 1/4 times 3/1, which equals 3/4. So the ratio between 1/3 and 1/4 is me multiplying 1/3 by 3/4 to get 1/4. Well, let's do the same to check our ratio here. 1/3 divided by 1/2. Well, now we end up with 2/3. Notice my rate is not the same. All right, it can't be geometric, so that knocks 1 off the list. Could it be arithmetic? Well, it's possible. We'd have to do a little bit of work to see if these fractions are a common ratio being added together. I like to work backwards, so 1/4 minus 1/3, give myself a common denominator. So 3/12 minus 4/12 equals negative 1/12. All right, let's check the other solution. 1/3 minus 1/2. That's going to be 6, and 6 is a common denominator. 3 times 2 is 6. 1 times 2. 3/6, which gives us negative 1/6. And we can see negative 1/6 is not the same as negative 1/12. So this would be an example of neither. The explicit form. Now, it's helpful for us to understand some of these terms. A sub n we talked about with arithmetic sequences, but A sub n is any given term. A sub 1, well, the 1 there indicates that it's our first term. The R, we've already talked about in the previous slides, is our common ratio. And the n comes from our A sub n value. All right. So let's look. We have 3, 6, 12, 24. Again, I like to work backwards to find the common ratio. 24 divided by 2 is 12. 12 divided by 6 is 2. 6 divided by 3 is 2. So we have a common ratio of 2. We also have a first term, that's easy to see, is 3. So using our notation from explicit form, we want to say that A sub n is equal to our value of A sub 1, 3, times our rate, 2, raised to the n minus 1. And that's our explicit form of the sequence. All right, let's try another. Negative 80 divided by negative 20. Now that's a common difference of 4. Negative 20 divided by negative 5, that's also a common difference of 4. So my common difference, or my common ratio, is 4. My a sub 1, my first term, is equal to negative 5. And so now we should be able to use our explicit form formula. A sub n is equal to negative 5 times 4 to the n minus 1. Write out the explicit form for each sequence. First thing we're going to do is figure out the value of our common ratio. So we work backwards. 10 over 30, is equal to 1/3. 30 over 90 is also equal to 1/3. And so your common ratio is 1/3. Your first term, a sub 1, is equal to 90. And so we end up with the explicit form formula for a geometric sequence that is a sub n is equal to 90 times 1/3 raised to the n minus 1 power. All right. Negative 152 over 156. We know it's going to give us a negative solution. So I'm going to plug that in my calculator because it's a pretty big number. And it looks like we end up with 0.3 repeating, which we know to be 1/3. All right, 156 divided by negative 468. That's also a negative number. And that also gives us 1/3. So our common ratio is equal to negative 1/3. Our first term is equal to negative 468. And so now we can write the explicit form. A sub n is equal to negative 468 times negative 1/3 to the n minus 1 power. All right, now we're dealing with fractions. Fractions don't have to be scary. We just have to take them one step at a time. So again, I like to work backwards. We're looking for a common ratio that is a multiple. So we're dividing 8/5 times the reciprocal, 5/4. 5s will simplify out. 4 goes into 8 2 times. All right, let's check the next ratio. 4/5 times the reciprocal. 5s will simplify out. 2 goes into 4 2 times. So we have a common ratio of 2. We have a first term of 2/5. So we end up with a sub n is equal to 2/5 times our common ratio raised to the n minus 1 power. All right, number 6. And of course, remember, anytime you feel confident enough to try a problem on your own, you're always welcome to pause, give it a shot, and then go through and check your answer as I'm working through it. So again, let's look for a common ratio. 6/5 times the reciprocal equals 6/9, which is 2/3. All right, 9/5 times the reciprocal which is going to equal, 2/3. Okay, so we've got a common ratio, we've got a first term. Our rate is equal to 2/3. Our a sub 1 is equal to 27/10. So we can write a explicit form sequence formula. A sub n is equal to 27/10 times 2/3 to the n minus 1 power. All right, recursive form. Recursive form is the one that I prefer less. The reason why I prefer it less is in order to find any given term, you need to know the previous term, which is why you're taking n minus 1, and multiply it by the rate. Well, if I know the previous term and I know the rate, I'm not going to use a formula to find the next term. I'm just going to multiply by that rate. So I think this one, while functionally practical and probably more applicable to programming, is less preferred when it comes to actually practicing. But ultimately, we need to know two things. We need to know what a sub 1 is, and we need to be able to write the recursive form. So let's start. Our a sub 1 value is going to be easy when we have a sequence. So a sub 1 is equal to 15. Now I just need to know my value of r. So again, we're going to work backwards. 3/5 times the reciprocal, 1/3. 3's will simplify out, and we end up with 1/5. So we have the r value. Let's check the rest. Sorry. 3 divided by 15 is equal to 1/5. So we have our r value equaling 1/5. We can set up our recursive form formula. A sub n is equal to a sub n minus 1 times 1/5. All right, let's try that again. I'm going to go ahead and find my common rate. So 32.5 divided by 6.5 gives me 5. 6.5 divided by 1.3, that also gives me 5. So I know my rate is equal to 5. Since we know my rate, we can take our first term, which is our a sub 1. A sub 1 is equal to 1.3. A sub n then is equal to a sub n minus 1. In other words, the previous term times 5. All right, directions say find the first three terms, find a sub 10, write the recursive form for each sequence, write the explicit form for each sequence. Now, I'm going to work backwards because I actually like to have the explicit form when I'm finding a sub 10. So I'm going to start with D and get the explicit form formula. A sub n is equal to a sub 1, which was given to us, so 3, times r, which is negative 2, raised to the n minus 1. Well, since I was given a sub 1 and r, I may as well go ahead and find my recursive formula as well. So C, that's going to give me a sub n is equal to a sub n minus 1 times my rate of negative 2. When a sub 1 is equal to 3. All right, let's go on to D. And D, I said I like the explicit form formula for being able to solve because we can say a sub 10 is equal to a sub 1 times negative 2 raised to the 10 minus first power. Well, that's going to give me 3 times negative 2 raised to the 9th power. You know, negative 2 to the 9th power is negative 512, which is still getting multiplied by 3. And so ultimately we end up with a sub 10 being negative 1,536. All right, that was B. Let's go up to A. The first three terms. Now, you are welcome to do this same process to find your first three terms. But to be honest, if I was given A sub 1 and it's 3, that's my first term. My second term is getting multiplied by negative 2. My third term is getting multiplied by negative 2. We now have our first three terms. All right, let's do it again. a sub 3 is equal to 24. Well, this presents a slightly different dilemma. We don't know a sub 1. But hopefully you're picking up to the pattern that these are multiples. We could certainly say, hey, divide by 2 so that I can figure out what number I multiplied by 2 to get 24. So a sub 2 would be 12. Well, a sub 1 then, we would divide by 2 again, and we would get 6. So we found our first 3 terms. But I want to give you a slightly modified version so that you can use it anytime you need it. That modified version is to take your a sub 3 value and plug it into your explicit formula. So a sub 3 is equal to a sub 1 times my rate raised to the n minus 1 power. Well, we just said n was 3. So n minus 1. Now I'm going to do 2 more things in my next step. I'm going to substitute for a sub 3 because we know the value of a sub 3. I'm also going to simplify 3 minus 2. And hopefully you're seeing, hey, you can square 2. So 24 is equal to a sub 1 times 4. At which point we can divide by 4. And we get that 6 is equal to a sub 1. Well, that's what we calculated previously using logic. But now we were able to use the explicit form formula to simplify the given information down into the same solution. So I'm not going to worry about our first 3 terms because we already have them here. They're not going to change. But I am going to write my explicit formula. So a sub n is equal to a sub 1, which we determined to be 6, times the rate, which we determined to be 2, raised to the n minus first power. With the explicit formula, I can say a sub 10 is equal to 6 times 2 raised to the 10 minus 1, which is 9th power. All right. And 2 raised to the 9th power, we saw it before. A sub 10 is equal to 6 times 512. And so our a sub 10 value is equal to 3072. All right, so we've got A, which is our first 3 terms. We've got B, which is our a sub 10 value. We've got C, which is our D, which is our explicit form formula. The only thing we're missing is C. So we want a sub n being equal to a sub n minus 1 times the rate. Well, we can remember we were given the rate at the beginning. It's 2. And a sub 1 we calculated to be 6. Graphing sequences. Now we can graph sequences by making all of our sequence terms y values and the order of them x values. All right. I'm going to modify my graph just a little bit so I can make sure these numbers fit on. So 6, 12, 18, 24, 30. All right. We come over 1, we come up 28. I'm going to make an X so you guys can see it a little bit better. We come over 2, we come up 14. We come over 3, you come up 7. We come over 4, you come up 3.5. And now we've got all 4 of our sequence values graphed on the graph. Notice, I have not attached a line. I have not extended it so it goes on and on forever. This is what we consider discrete data. Discrete data is not continuous. It does not go on and on forever. Yes, the sequence can go on and on forever, but the domain is limited in that it's starting with our first term. Now, that begs the question, what is the domain? The domain is every x value on our coordinate plane that is a integer value. Sorry, a natural number value. In other words, 0 is not part of the domain. We don't have a 0th term. You always start with your first term. -1 is not part of the domain. You don't have a negative first term. You always start with your first term. So, the domain is going to always be your natural numbers, because your first term in the sequence is always going to be number 1. The range. Now with range, you just repeat your list of your sequence. 28, 14, 7, 3.5, ... Because again, your range is just those values, 28, 14, 7, 3.5, and anything that follows that sequence. Okay, I'm going to let you try 12. I'm not going to do 12 today on video because I want to get to some of these other problems. Given the two terms in a geometric sequence, find the explicit and recursive form. Well, notice I'm not given an a sub 1. And I'm not given a rate to quickly, easily decide what a sub 1 is going to be. Which means we've got a slightly different process taking place here. We're going to use the formula a sub n is equal to a sub 1 times r to the n minus 1 power. Now, one of the things that's important for us to capture here is, say I gave you the 54th power, or 54th term. If I plug a 54 in for n, we are subtracting 54 minus 1, and that tells me that there are 53 values between my first term and my 54th term. Now, we're going to use that concept to be able to modify this formula. So we're always going to take our largest sequence value and put it outside. So a sub 4 is equal to, and instead of a sub 1, it's now going to be a sub 2 so that we can find the common rate. A sub 2 times r to the n minus 1. Now let's think about the n minus 1. Previously we said the n minus 1 would have been 54 minus 1, so that would have been a difference of 53 terms. We now want to know the difference between the set of terms a4 and a2. So we're looking for a value of 4, our n value still, minus 2, our a sub connected with the rate. So let's substitute values and simplify. A sub 4 is 1 equals a sub 2 is 4 times the rate raised to the second power. And we'll divide both sides by 4. And 1/4 is equal to my rate squared. All right, take the square root of both sides. And r would be equal to square root of 1, which is 1, square root of 4, which is 2. We now know the r value. Now, since a sub 2 is such a low value, we could certainly understand the process to think backwards for finding a. Or you can use the arithmetic sequence again, this time trying to find the value 1. So I want to model that one. For this one, we might shortcut on the next. A sub 2 is equal to a sub 1 times the rate raised to the n minus 1. All right. So we can plug in what we know a sub 2 is. 4 is equal to a sub 1 times 1/2. 2 minus 1 is 1. So we have 4 being equal to a sub 1 times 1/2, which we know we can multiply by the reciprocal. And a sub 1 will be equal to 8. Now we know a sub 1 and we know the rate. We can find the explicit and recursive formulas. All right, explicit form is going to be a sub n is equal to 8 times 1/2 to the n minus 1 power. My recursive form, a sub 1 is equal to 8, where a sub n is equal to a sub n minus 1 times 1/2. Again, I'll let you apply that to question 14. We're going to do more